Langchain Prompty Core. Description: explain in detail. Langchain Prompty is a powerful tool for creating and managing prompts for large language models (LLMs). It offers a user-friendly interface for prompt engineering, allowing users to easily define, test, and optimize prompts for various NLP tasks. Inputs. Input 1. Explain in detail. Prompt template: a string containing the basic structure of the prompt, including placeholders for user inputs. Input 2. Explain in detail. User inputs: the specific values that will be inserted into the prompt template. Outputs. Output 1. Explain in detail. Generated text: the output generated by the LLM based on the constructed prompt. Output 2. Explain in detail. Metrics: a set of metrics, e.g., accuracy, fluency, relevance, that evaluate the quality of the generated text. Steps. Step 1. Explain in detail. Prompt construction. Langchain Prompty takes the prompt template and user inputs and dynamically constructs a complete prompt for the LLM. Step 2. Explain in detail. LLM execution: the constructed prompt is sent to the LLM for processing, and the LLM generates the desired text output. Metrics. Metric 1. Explain in detail. Accuracy measures how accurately the LLM fulfills the user's intent. Metric 2. Explain in detail. Fluency evaluates the grammatical correctness and readability of generated text. Visualization plots. Visualization plot 1. Explain in detail. Prompt performance over time: a visualization that shows how the performance of the prompt changes over time, allowing users to track progress and identify areas for improvement. Visualization plot 2. Explain in detail. Prompt performance across different user inputs: a visualization that shows how the performance of the prompt varies across different types of user inputs. Fine-tune parameters. Parameter 1. Explain in detail. Prompt weight adjusts the relative importance of different parts of the prompt, allowing users to fine-tune the LLM's focus. Parameter 2. Explain in detail. Temperature controls the randomness of the LLM's output, allowing users to balance between creativity and consistency. Uncertainty methods. Uncertainty method 1. Explain in detail. Confidence scores provides an indication of the LLM's confidence in its generated text, helping users identify potentially unreliable outputs. Uncertainty method 2. Explain in detail. Ensemble models utilizes multiple LLMs to generate outputs, combining predictions and improving reliability. Challenges and fixes. Challenge 1. Explain in detail. Prompt ambiguity: the prompt may be unclear or open to multiple interpretations, leading to unexpected or incorrect outputs. Sample use case that resulted in challenge 1. A prompt asking for a summary without specifying length or desired level of detail may result in overly brief or excessively long summaries. Fixes to challenge 1. Clearly define the desired output format, specify the length of the summary, and provide context to guide the LLM. Challenge 2. Explain in detail. Data bias: the LLM's training data may contain biases, leading to biased or discriminatory outputs. Sample use case that resulted in challenge 2. A prompt asking for a list of famous scientists might disproportionately include male scientists due to historical biases in the scientific community. Fixes to challenge 2. Use diverse and unbiased training data, implement the biasing techniques, and carefully evaluate the generated outputs for potential biases. YAML. Langchain Prompty Core. Front matter. Description: the Langchain Prompty Core is a Python library that provides a simple and efficient way to create and use prompts for Langchain applications. It offers a user-friendly interface for defining prompts, including variables, templates, and examples, along with methods for generating prompt text and evaluating prompt performance. Inputs. Prompt template: a string containing the template of the prompt, which can include variables to be filled in with specific values during execution. Variables: a dictionary of key value pairs representing the variables to be used in the prompt. Template. Examples: a list of prompt response pairs that serve as examples for the language model to learn from and improve its performance. Constraints: optional constraints that specify limitations or specific requirements for the output generated by the prompt. Outputs. Prompt text: a string representing the final prompt text generated after filling in the variables in the template. Response: the output generated by the language model when given the prompt text. Steps. Template definition: define the prompt template with placeholders for variables. Variable initialization: provide values for the variables to be used in the prompt. Prompt generation: generate the final prompt text by filling in the variables in the template. Model execution: execute the prompt using a Langchain model, such as a large language model (LLM). Response processing: process the response generated by the model, potentially performing post-processing tasks like filtering or formatting. Metrics. Prompt effectiveness: measures how well the prompt elicits desired responses from the language model, considering factors like relevance, accuracy, and completeness. Response quality: evaluates the quality of the generated responses based on criteria such as clarity, coherence, and adherence to constraints. Model performance: measures the performance of the language model in generating responses according to the prompt's instructions. Visualization plots. Prompt template visualization visualizes the prompt template structure, highlighting variables and their relationships. Response analysis generates visualizations to analyze the responses generated by the model, identifying trends and patterns. Model performance plots displays plots of key performance metrics to track model behavior and evaluate its effectiveness. Fine-tune parameters. Temperature controls the randomness of the model's output, with higher values leading to more creative and unexpected responses. Top K specifies the number of top scoring tokens to consider during decoding, influencing the diversity and quality of the output. Top determines the probability threshold for selecting tokens, with lower values favoring more predictable and conservative responses. Uncertainty methods. Temperature sampling introduces randomness into the output by sampling tokens based on their probabilities, capturing potential variations in responses. Beam search explores multiple candidate sequences in parallel, selecting the best scoring path according to a defined metric. Nucleus sampling selects tokens based on their cumulative probability distribution, controlling the diversity and predictability of the output. Challenges and fixes. Challenge 1: overly generic prompts can lead to ambiguous or irrelevant responses. Sample use case that resulted in challenge 1: a prompt asking "tell me about a famous person" resulted in a response about a random person without any specific context or criteria. Fixes to challenge 1. Provide specific context or constraints in the prompt. For example, tell me about a famous person who is known for their contributions to science. Use prompt engineering techniques to guide the model towards desired responses, such as providing examples or specifying the desired response format. Challenge 2: prompts that are too complex or lengthy can overwhelm the model, leading to errors or inconsistent outputs. Sample use case that resulted in challenge 2: a prompt with multiple nested clauses and complex logical relationships resulted in a confused and incoherent response. Fixes to challenge 2. Break down complex prompts into smaller, More manageable units. Use simpler language and avoid jargon or technical terms that the model might not understand. Employ prompt engineering techniques like chunking or chaining to divide the task into smaller steps. Langchain Prompty Core Invoker. Description: explain in detail. The invoker is the core class in Langchain Prompty for executing prompts. It provides a standardized interface for prompt execution, including managing input and output, applying transformations, and tracking metrics. Inputs. Input 1. Explain in detail the prompt itself. A string containing the textual prompt to be executed. Input 2. Explain in detail context. An optional dictionary or other data structure containing relevant context for the prompt execution. This could include variables, previous outputs, or external knowledge sources. Outputs. Output 1. Explain in detail output. A string containing the raw text output generated by the prompt execution. Output 2. Explain in detail metrics. A dictionary containing key value pairs that represent various metrics associated with the prompt. Execution, such as execution time, token count, or error codes. Steps. Step 1. Explain in detail. The invoker first takes the input prompt and context and optionally processes them using any registered prompt transformations, e.g., variable substitution, template rendering. Step 2. Explain in detail. The invoker then executes the prompt against the desired backend, e.g., a language model, a database, or a script. Metrics. Metric 1. Explain in detail execution time. The duration of the prompt execution in seconds. Metric 2. Explain in detail token count. The number of tokens used in the prompt execution. Visualization plots. Visualization plot 1. Explain in detail a time series plot showing the execution time of the prompt over time. Visualization plot 2. Explain in detail a histogram showing the distribution of token counts for the prompt. Fine-tune parameters. Parameter 1. Explain in detail temperature controls the randomness of the generated output. Higher values lead to more creative and unpredictable responses. Parameter 2. Explain in detail top limits the number of potential outputs considered at each step during the generation process. Uncertainty methods. Uncertainty method 1. Explain in detail confidence scores. Return confidence scores for each generated token, indicating the model's uncertainty about the prediction. Uncertainty method 2. Explain in detail temperature scaling. Adjust the temperature parameter based on the model's confidence scores to increase uncertainty in areas of low confidence. Challenges and fixes. Challenge 1. Explain in detail prompt execution errors. Errors can occur during prompt execution due to issues like invalid inputs, connection failures, or unexpected responses from the backend. Sample use case that resulted in challenge 1. A prompt attempting to access a database throws an error due to a wrong connection string. Fixes to challenge 1. Implement robust error handling mechanisms that capture and log errors. Provide informative error messages, and optionally retry the execution with different parameters. Challenge 2. Explain in detail prompt ambiguity. The prompt may be poorly worded or ambiguous, leading to inconsistent or unexpected outputs. Sample use case that resulted in challenge 2. A prompt asking for a summary of a document might generate different summaries depending on the specific interpretation of the prompt. Fixes to challenge 2. Use clear and unambiguous prompt language. Provide explicit instructions and constraints, and leverage techniques like prompt engineering to improve the prompt's clarity and specificity. Langchain Prompty Core Invoker Factory. Description. Explain in detail. The Invoker Factory class is responsible for creating instances of invokers, which are objects that execute prompts and return results. It provides a way to define and manage different invoker configurations, such as using different language models, prompt templates, or execution strategies. Inputs. Input 1. Explain in detail invoker type, a string representing the type of invoker to create, such as LLM, tool, or chain. Input 2. Explain in detail config, a dictionary containing configuration options for the specific invoker type. This may include parameters like the language model to use, the prompt template, or the execution strategy. Outputs. Output 1. Explain in detail an invoker instance that can be used to execute prompts. Steps. Step 1. Explain in detail the invoker factory, checks the provided invoker type and retrieves the corresponding invoker configuration from a registry of available invokers. Step 2. Explain in detail the factory uses the config dictionary to instantiate an invoker object with the specified configuration. Metrics. Metric 1. Explain in detail, not applicable. Metric 2. Explain in detail, not applicable. Visualization plots. Visualization plot 1. Explain in detail, not applicable. Visualization plot 2. Explain in detail, not applicable. Fine-tune parameters. Parameter 1. Explain in detail, not applicable. Parameter 2. Explain in detail, not applicable. Uncertainty methods. Uncertainty method 1. Explain in detail, not applicable. Uncertainty method 2. Explain in detail, not applicable. Challenges and fixes. Challenge 1. Explain in detail handling custom invoker types. Sample use case that resulted in challenge 1. If a user wants to define a new invoker type that is not included in the default registry, the invoker factory needs a way to accommodate this custom type. Fixes to challenge 1. The invoker factory can be extended to allow users to register their own custom invoker types by providing a callback function or a class definition. This allows for flexible extension and customization. Challenge 2. Explain in detail ensuring compatibility between different invokers and prompt templates. Sample use case that resulted in challenge 2. If a prompt template is designed for a specific invoker type, e.g., a language model with certain capabilities, using it with a different invoker type, e.g., a tool that does not have those capabilities may result in unexpected behavior. Fixes to challenge 2. The invoker factory can include validation mechanisms to ensure that a specified prompt template is compatible with the selected invoker type. It can also provide guidance or error messages to help users identify potential compatibility issues. Langchain Prompty Core Model Settings. Description model settings is a class that provides a standardized way to define and manage the configuration settings for various components within Langchain, specifically within the Prompty module. It facilitates clear organization, consistency, and flexibility when setting up your Langchain applications. Inputs. Model name specifies the underlying language model that powers the prompt engineering process. Examples include GPT 3.5 Turbo, Text DaVinci 003, or Flan T5 XL. Prompt template defines the structure of the prompt using placeholders for inputs and desired outputs. The prompt template dictates the format of how instructions are given to the language model. Input data. The data used as input to the prompt template. This can be text, code, structured data, or other types of information that the model will process. Model parameters. Configuration settings for the chosen language model, such as temperature, top, and max tokens. Outputs. Generated text. The text output generated by the language model based on the provided prompt and input data. Output structure depending on the prompt template. The output can be structured into specific formats, such as lists, tables, or JSON objects. Steps. Prompt construction. The input data and prompt template are combined to create a complete prompt. Model execution. The language model processes the constructed prompt and generates an output. Output processing. The generated text output is post-processed according to the specified format and desired structure. Metrics. Accuracy evaluates how well the generated output matches the expected outcome. Coherence measures the fluency and logical consistency of the generated text. Relevance assesses the extent to which the output is relevant to the given input and task. Visualization plots. Prompt structure. Visualization displays the structure and key elements of the prompt template. Output data distribution visualizes the distribution of different data types or categories in Pay. Generated output. Fine-tune parameters. Learning rate controls the step size taken during training. Epochs. Number of times the entire training dataset is processed. Batch size. Number of training examples processed in a single iteration. Uncertainty methods. Temperature sampling introduces randomness in the model's output by adjusting the probability. Distribution of words. Top K sampling selects the top K most probable words for generation. Challenges and fixes. Challenge 1. Overfitting. The model learns the training data too well and may not generalize to unseen data. Sample use case that resulted in challenge 1. A model trained on a specific dataset of news articles performs well on that dataset but struggles to generate coherent text for articles from different domains. Fixes to challenge 1. Use a larger and more diverse training dataset. Regularize the model during training to prevent overfitting. Challenge 2. Bias and fairness. The model may exhibit biases present in the training data. Sample use case that resulted in challenge 2. A model trained on text with gender stereotypes may generate biased outputs, perpetuating those stereotypes. Fixes to challenge 2. Ensure the training data is balanced and diverse. Use fairness metrics to evaluate and mitigate bias during model development. Challenge 3. Interpretability. Understanding how the model arrives at its predictions can be difficult. Sample use case that resulted in challenge 3. It can be challenging to explain why a model generated a specific piece of text, especially with complex models like large language models. Fixes to challenge 3. Use techniques like attention visualization to understand which parts of the input text the model focuses on. Develop methods to extract insights from the model's internal workings. Challenge 4. Prompt engineering. Designing effective prompts is a crucial yet often challenging aspect. Sample use case that resulted in challenge 4. A poorly designed prompt can lead to inaccurate or irrelevant output from the model. Fixes to challenge 4. Use best practices for prompt construction and experimentation. Leverage tools and techniques like prompt engineering libraries for guidance. Langchain Prompty Core No-op parser. Description. Explain in detail. The no-op parser is a simple parser that does not perform any parsing. It simply returns the input string as is. This can be useful for situations where you want to use a parser but don't want to do any actual parsing. Inputs. Input 1. Explain in detail a string that represents the input to be parsed. Outputs. Output 1. Explain in detail the input string. Unparsed. Steps. Step 1. Explain in detail. No parsing is performed. Metrics. Metric 1. Explain in detail. Not applicable. Metric 2. Explain in detail. Not applicable. Visualization plots. Visualization plot 1. Explain in detail. Not applicable. Visualization plot 2. Explain in detail. Not applicable. Fine-tune parameters. Parameter 1 explain in detail not applicable. Parameter 2 explain in detail not applicable. Uncertainty methods. Uncertainty method 1 explain in detail not applicable. Uncertainty method 2 explain in detail not applicable. Challenges and fixes. Challenge 1 explain in detail not applicable. Challenge 2 explain in detail not applicable. Langchain Prompty Co Prompty. Description Prompty is a powerful framework built on Langchain for developing interactive and iterative prompts for large language models. It enables the creation of complex prompts that involve multiple steps, user inputs, and conditional branching. This allows for building prompts that can guide conversations, explore different ideas, and generate creative outputs. Inputs. Prompt template: a string representing the template for the prompt. It may include placeholders that will be filled with dynamic values. Input values: a dictionary containing values that will be used to populate the prompt template. These values can come from user input, external data sources, or previous responses from the LLM model, the LLM instance that will be used to execute the prompt. Outputs. Response: the output generated by the LLM based on the provided prompt. Metadata: a dictionary containing information about the prompt execution, including timestamps, input values, and other relevant data. Steps. Prompt building: define the structure of the prompt using a template. This template can include variables that will be filled dynamically. Input handling: process user inputs or retrieve data from external sources to populate the prompt. Template. Model execution: pass the complete prompt to the LLM for processing and response generation. Output handling: interpret and process the LLM response, potentially extracting relevant information or formatting the output. Metrics. Prompt execution time: measure the time taken to execute the prompt and generate a response. Response quality: assess the quality of the generated response using metrics like coherence, relevance, and factuality. User satisfaction: evaluate the user's experience with the prompt through feedback mechanisms or satisfaction surveys. Visualization plots. Prompt structure visualization: a graphical representation of the prompt structure, highlighting the flow of information and dependencies. Response analysis plots: visualizations that analyze the characteristics of the generated responses, such as word frequency, sentiment, or topic distribution. Fine-tune parameters. Temperature: a value that controls the randomness of the LLM's output. Higher values lead to more creative and diverse responses, while lower values produce more predictable and consistent outputs. Top: a parameter that restricts the probability distribution of the LLM's output to the top p most likely tokens. This can improve the quality and coherence of the generated text. Top k: a similar parameter to top, but it restricts the output distribution to the top k most likely tokens. Uncertainty methods. Temperature sampling: generate multiple responses with different temperature values to explore a range of possible outputs. Ensemble sampling: run the prompt on multiple LLM models to obtain a consensus response. Challenges and fixes. Challenge 1: prompt ambiguity: prompts that are unclear or open to multiple interpretations can lead to inaccurate or irrelevant responses. Sample use case that resulted in Challenge 1: a prompt asking what is the best restaurant in the city, without providing any context or specific criteria, might generate vague or unhelpful responses. Fixes to Challenge 1: provide more specific context, guidance, and constraints in the prompt to reduce ambiguity and guide the LLM towards desired outcomes. Challenge 2: response inconsistency. The LLM might generate inconsistent responses for similar prompts due to stochasticity or variations in the training data. Sample use case that resulted in challenge 2: a prompt asking for a short story about a cat might generate significantly different stories with varying plot lines, characters, and themes on different runs. Fixes to challenge 2: use techniques like temperature sampling or ensemble sampling to explore different possible responses and identify patterns or common themes. This can help to ensure consistency and reduce the impact of randomness. Challenge 3: overly general responses. The LLM may provide generic or uninformative responses when the prompt lacks specific constraints or guidance. Sample use case that resulted in challenge 3: a prompt asking what is the meaning of life might generate a generic philosophical response without providing concrete insights or examples. Fixes to challenge 3: provide specific constraints and guidance to the prompt, such as asking for a specific perspective, a particular style, or a concrete example to encourage the LLM to generate more focused and informative responses. Challenge 4: response length control. Difficulty in controlling the length of the generated responses to meet specific requirements. Sample use case that resulted in challenge 4: a prompt asking for a short summary of a topic might generate a lengthy and detailed response exceeding the desired length. Fixes to challenge 4 include specific length constraints in the prompt, such as setting a maximum word count or using parameters like max tokens to guide the LLM's response length. Challenge 5: handling long input sequences. Prompts with extensive context or long input sequences can exceed the LLM's memory limitations or processing capacity. Sample use case that resulted in challenge 5: a prompt requiring the LLM to process a lengthy document or a series of previous interactions might result in incomplete or inaccurate responses due to memory limitations. Fixes to challenge 5: use techniques like chunking or summarization to break down long input sequences into manageable chunks, allowing the LLM to process information more efficiently. Challenge 6: data leakage. The LLM might inadvertently reveal or generate outputs that include sensitive or confidential information from the training data. Sample use case that resulted in challenge 6: a prompt asking for a creative story might generate a response that contains phrases or characters from the LLM's training data, potentially exposing sensitive information. Fixes to challenge 6: implement data anonymization or redaction techniques to remove sensitive information from the training data before it is used by the LLM. This helps to ensure the privacy and security of user data. Challenge 7: prompt engineering difficulty. Designing effective and efficient prompts can be challenging, requiring a deep understanding of the LLM's capabilities and limitations. Sample use case that resulted in challenge 7: a prompt that is poorly worded or structured might lead to unexpected or unhelpful responses, requiring extensive iterations to achieve the desired outcome. Fixes to challenge 7: leverage techniques like prompt engineering best practices, explore existing prompt libraries, and iterate on the prompt design based on feedback and experimentation to improve its effectiveness. Langchain Prompty Core Property Settings. Description. Property settings is a class in the Langchain Prompty library that defines the settings for a property. It allows you to specify the inputs, outputs, steps, metrics, visualization plots, fine-tune parameters, uncertainty methods, and challenges associated with a particular property. This class helps in organizing and documenting the properties and provides a structured way to manage them. Inputs. Input 1. This parameter represents the input data required for the property. It can be a single value or a list of values. The type and format of the input data should be defined here. Input 2. This parameter represents the second input data required for the property. If any, the type and format of this input data should be defined here. Outputs. Output 1. This parameter represents the output of the property. It describes the type and format of the expected output. This could be a single value, a list of values, a dictionary, etc. Output 2. This parameter represents the second output of the property. If any, it describes the type and format of the expected output. This could be a single value, a list of values, a dictionary, etc. Steps. Step 1. This parameter defines the first step involved in the property calculation or process. It could involve specific calculations, transformations, or function calls. Step 2. This parameter defines the second step involved in the property calculation or process. It could involve specific calculations, transformations, or function calls. Metrics. Metric 1. This parameter represents the first metric used to evaluate the property. It defines the metric type and the method for calculating it. This could be accuracy, precision, recall, F1 score, etc. Metric 2. This parameter represents the second metric used to evaluate the property. It defines the metric type and the method for calculating it. This could be accuracy, precision, recall, F1 score, etc. Visualization plots. Visualization plot 1. This parameter defines the first visualization plot used to represent a property. It describes the type of plot and the data used to generate it. This could be a line chart, bar chart, scatter plot, etc. Visualization plot 2. This parameter defines the second visualization plot used to represent a property. It describes the type of plot and the data used to generate it. This could be a line chart, bar chart, scatter plot, etc. Fine-tune parameters. Parameter 1. This parameter defines the first parameter used for fine-tuning the property. It describes the parameter name, its type, and its default value. Parameter 2. This parameter defines the second parameter used for fine-tuning the property. It describes the parameter name, its type, and its default value. Uncertainty methods. Uncertainty method 1. This parameter defines the first uncertainty method used for quantifying a uncertainty associated with the property. It describes the method and any associated parameters. Uncertainty method 2. This parameter defines the second uncertainty method used for quantifying a uncertainty associated with the property. It describes the method and any associated parameters. Challenges and fixes. Challenge 1. This parameter describes the first challenge encountered while working with a property. It includes a detailed explanation of the challenge and a sample use case that resulted in it. Sample use case that resulted in challenge 1. This provides an example of how the challenge manifested during the property's application. Fixes to challenge 1. This section outlines the solutions or workarounds developed to address a challenge. Challenge 2. This parameter describes the second challenge encountered while working with a property. It includes a detailed explanation of the challenge and a sample use case that resulted in it. Sample use case that resulted in challenge 2. This provides an example of how the challenge manifested during the property's application. Fixes to challenge 2. This section outlines the solutions or workarounds developed to address a challenge. Langchain Prompty को simple model. Description explain in detail. The simple model is a basic building block for creating prompt templates in Langchain. It provides a straightforward way to define a prompt with input and output parameters and a simple template string. This model is ideal for scenarios where you need a simple and customizable prompt structure without the complexity of more advanced models. Inputs. Input 1. Explain in detail. The input parameters of the simple model are the variables that will be filled in when the prompt is generated. These can be any kind of data, such as text, numbers, or lists. Each input is defined as a key-value pair within the model's configuration. Input 2. Explain in detail. The input parameters of the simple model are the variables that will be filled in when the prompt is generated. These can be any kind of data, such as text, numbers, or lists. Each input is defined as a key-value pair within the model's configuration. Outputs. Output 1. Explain in detail. The output of the simple model is the generated prompt string. This string will contain the template text with the input parameters filled in. Output 2. Explain in detail. The output of the simple model is the generated prompt string. This string will contain the template text with the input parameters filled in. Steps. Step 1. Explain in detail. The simple model operates in a straightforward manner. It takes the provided input parameters and substitutes them into the template string. Step 2. Explain in detail. The simple model operates in a straightforward manner. It takes the provided input parameters and substitutes them into the template string. Metrics. Metric 1. Explain in detail. The simple model itself does not provide specific metrics for evaluation. The effectiveness of the generated prompt depends on the quality of the template and the relevance of the input data. You can use metrics like prompt engineering scoring, human evaluation, and downstream task performance to measure the effectiveness of the generated prompts. Metric 2. Explain in detail. The simple model itself does not provide specific metrics for evaluation. The effectiveness of the generated prompt depends on the quality of the template and the relevance of the input data. You can use metrics like prompt engineering scoring, human evaluation, and downstream task performance to measure the effectiveness of the generated prompts. Visualization plots. Visualization plot 1. Explain in detail. The simple model itself does not offer built-in visualization plots. However, you can visualize the prompt template structure and the input-output parameters using tools like graph visualization libraries or text-based representations. Visualization plot 2. Explain in detail. The simple model itself does not offer built-in visualization plots. However, you can visualize the prompt template structure and the input-output parameters using tools like graph visualization libraries or text-based representations. Fine-tune parameters. Parameter 1. Explain in detail. The simple model does not have specific fine-tuning parameters. The customization lies in defining the prompt template and the input-output parameters. Parameter 2. Explain in detail. The simple model does not have specific fine-tuning parameters. The customization lies in defining the prompt template and the input-output parameters. Uncertainty methods. Uncertainty method 1. Explain in detail. The simple model does not provide uncertainty estimates. You can explore uncertainty quantification techniques using techniques like Bayesian inference or ensemble methods to estimate the confidence in the generated prompt. Uncertainty method 2. Explain in detail. The simple model does not provide uncertainty estimates. You can explore uncertainty quantification techniques using techniques like Bayesian inference or ensemble methods to estimate the confidence in the generated prompt. Challenges and fixes. Challenge 1. Explain in detail. It can be difficult to create a prompt template that is general enough to handle a wide range of inputs while still being specific enough to generate relevant outputs. Suppose you have a prompt template for summarizing a news article. If the template is too general, it may not capture all the important information. If it's too specific, it may not be able to handle different types of articles. Start with a simple template and iteratively refine it based on feedback. You can also use techniques like prompt engineering and prompt libraries to find existing templates that can be adapted to your needs. Challenge 2. Explain in detail. The simple model does not handle nested structures or complex logical operations within the prompt template. Suppose you want to create a prompt that generates a code snippet based on a set of conditions. The simple model would not be able to handle this scenario because it does not support conditional logic or nested structures. Consider using a more advanced prompt model like the chain of thought model or the few-shot learning model to handle complex logic and nested structures within the prompt. Langchain Prompty Core Template Settings. Description Template Settings is a class within the Langchain Prompty library that provides a framework for managing template-based prompts in a structured and customizable manner. It allows for defining inputs, outputs, steps involved in the prompt generation, metrics to evaluate the performance, visualization options, and parameters for fine-tuning the prompts. Inputs. Template. This is the main input that defines the structure of the prompt. It can be a simple string or a more complex template language expression. Inputs. A list of input variables that are used to populate the template. Each input can have a specific type, default value, and validation rules. Outputs. A list of output variables that are generated by the prompt. This can include text, lists, dictionaries, or other data structures. Steps. A list of steps that are performed during the prompt generation process. Each step can be a function, a method, or a series of operations that transform the input variables into the desired output. Outputs. Output. The final output generated by the prompt. Metrics. A dictionary of metrics that are used to evaluate the performance of the prompt. Visualizations. A list of visualizations that can be used to explore the data generated by the prompt. Steps. Validation ensures that the input variables meet the specified requirements. Templating populates the template with the input values. Execution executes the steps defined in the prompt. Post-processing performs any necessary transformations on the output. Metrics. Accuracy measures the correctness of the prompt's output. Fluency evaluates the smoothness and readability of the generated text. Coherence assesses the logical consistency and flow of the output. Informativeness determines how much relevant information is provided in the output. Visualization plots. Word cloud visualizes the frequency of words in the generated text. Bar chart shows the distribution of different categories or values in the output. Scatterplot represents the relationship between two variables in the data. Fine-tune parameters. Learning rate. The rate at which the model adjusts its parameters during fine-tuning. Epochs. The number of iterations over the training data. Batch size. The number of samples processed at each iteration. Uncertainty methods. Monte Carlo dropout uses dropout during inference to estimate the uncertainty in the models. Predictions. Bayesian neural networks incorporates prior beliefs about the model parameters to quantify uncertainty. Challenges and fixes. Challenge 1: Overfitting. Sample use case when the model learns the training data too well and fails to generalize to unseen data. Fixes. Regularization techniques like L1 and L2 penalties. Early stopping. Dropout. Challenge 2: Bias. Sample use case when the model exhibits unfair or prejudiced behavior due to biases in training data. Fixes. Data augmentation to introduce more diverse examples. Fairness metrics to monitor and mitigate biases. Preprocessing techniques to remove biased information. Challenge 3: Prompt engineering. Sample use case prompt engineering involves crafting effective prompts that elicit the desired responses from the model. This can be challenging as it requires understanding the model's strengths and weaknesses. Fixes. Experimenting with different prompt formats and structures. Utilizing prompt engineering techniques like few-shot learning, zero-shot learning, and chain-of-thought prompting. Iteratively refining the prompt based on feedback from the model's outputs. Langchain Prompty param hoisting. Description: param hoisting is a co-optimization technique in Langchain Prompty that enhances efficiency by reducing redundant parameter passing. It essentially hoists common parameters out of individual function calls, allowing them to be shared across multiple functions. Inputs: function calls with repetitive parameters. The desired set of shared parameters. Outputs: more concise function calls, reducing code clutter. Improved performance by minimizing parameter passing overhead. Steps: analyze the code to identify common parameters across multiple function calls. Define a parameter dictionary that stores the shared parameters. Modify function calls to reference the parameter dictionary instead of passing parameters directly. Metrics: code size reduction, execution time improvement, visualization plots, call graph visualization showcasing the reduction in parameter passing. Fine-tune parameters: the parameter dictionary structure and content. The granularity of parameter hoisting. Uncertainty methods: analyzing the frequency of parameter usage to identify suitable candidates for hoisting. Simulating different hoisting configurations to determine the optimal balance between performance and maintainability. Challenges and fixes. Challenge 1: over-hoisting can lead to decreased readability and maintainability if the parameter dictionary becomes too complex or large. Sample use case: hoisting all possible parameters into a single dictionary, making it difficult to understand which parameters are used by each function. Fixes: carefully select parameters for hoisting based on usage frequency and logical groupings. Divide large dictionaries into smaller, more manageable ones. Challenge 2: if the hoisting is not done correctly, it might inadvertently change the behavior of the functions due to altered parameter values or types. Sample use case: incorrectly hoisting a parameter with a different data type than expected by a function. Fixes: thoroughly test the code after implementing hoisting to ensure that function behavior remains consistent. Use type hints or static analysis tools to help identify potential type mismatches. YAML. Langchain Prompty. Langchain. Description: Langchain Prompty is a tool built on top of Langchain, designed to simplify the process of building and using prompt templates for large language models. LLMs. It provides a user-friendly interface for creating, testing, and deploying prompt templates. Inputs: prompt template: a string or a dictionary containing placeholders for input variables to be filled during execution. Input data to be used as input to the prompt template. usually in the form of a dictionary or a list of dictionaries. LLM, the language model to be used for execution, specified by its name or an instance of a LLM class. Outputs. Output text, the text generated by the LLM in response to the prompt template and input data. Prompt template modified in some cases. The prompt template itself might be modified during the process. For example, by adding more context or refining the instruction. Steps. Prompt template creation. Define the prompt template with placeholders for input variables. Input data loading. Load or generate the input data to be used with the prompt template. LLM execution. Execute the LLM with the prompt template and input data. Output processing. Process and format the output text generated by the LLM. Metrics. Prompt effectiveness measures the quality of the generated text, taking into account factors like coherence, relevance, and accuracy. Prompt length tracks the length of the prompt template to understand its impact on LLM. Performance. LLM performance metrics related to the LLM's response time, resource usage, and error rates. Visualization plots. Prompt template structure visualizes the structure of the prompt template, highlighting placeholders and their relationships. Output distribution plots the distribution of different types of outputs generated by the LLM. Prompt output relationship visualizes the correlation between prompt features and output. Characteristics. Fine-tune parameters. Temperature controls the randomness of the LLM's output, with higher values leading to more creative and unpredictable responses. Top K specifies the number of top K most likely tokens to consider during output generation, impacting the quality and diversity of the output. Top controls the probability mass of the tokens considered during output generation, influencing the diversity and coherence of the output. Uncertainty methods. Confidence scores. The LLM can provide confidence scores for generated tokens, indicating the model's certainty in its predictions. Multiple generations generate multiple outputs from the same prompt to understand the models. Variance and potential uncertainties. Ensemble methods combine outputs from multiple LLMs to improve robustness and reduce bias. Challenges and fixes. Challenge 1. Prompt ambiguity. Sample use case that resulted in Challenge 1. A prompt template with unclear instructions or conflicting information can lead to unexpected or irrelevant outputs. Fixes to Challenge 1. Clarify the prompt template by providing more specific instructions, examples, and context. Use structured prompts with clear delimiters to guide the LLM. Challenge 2. Overfitting to specific data. Sample use case that resulted in Challenge 2. Training an LLM on a highly specific dataset can lead to overfitting, resulting in poor performance on unseen data. Fixes to Challenge 2. Use a more diverse dataset for training. Employ techniques like data augmentation to introduce variability. Regularize the model during training to prevent overfitting. Challenge 3. Prompt length and complexity. Sample use case that resulted in Challenge 3. Excessively long or complex prompts can overwhelm the LLM, leading to poor performance or errors. Fixes to Challenge 3. Break down complex tasks into smaller, more manageable prompts. Use techniques like prompt engineering to refine and optimize the prompt for better LLM performance. Challenge 4. Handling long input data. Sample use case that resulted in Challenge 4. LLMs have limitations on the amount of input they can process at once, making it challenging to work with large datasets. Fixes to Challenge 4. Use techniques like chunking or summarization to break down large datasets into smaller units that can be processed efficiently. Employ specialized memory mechanisms to allow the LLM to access and recall past information. YAML. Langchain Prompty Langchain Create Chat Prompt. Description: the Create Chat Prompt function in Langchain is designed to simplify the creation of chat prompts, specifically for use with large language models (LLMs) in a conversational setting. It provides a structured way to define the inputs, outputs, steps, and additional considerations for building effective chat prompts. Inputs. Chat history: a list of tuples, where each tuple represents a turn in the conversation. Each tuple consists of the role, e.g., user or assistant, and the message content. Human input: the user's latest input to the conversation. This is the prompt that the LLM will receive. Additional quarks: optional keyword arguments that can be used to customize the prompt further, such as specifying the desired response format or providing context information. Outputs. Prompt: a string representing the complete chat prompt that is sent to the LLM. This prompt is constructed based on the chat history, human input, and any additional keyword arguments. Steps. The function first assembles the conversation history into a format suitable for the LLM. This may involve adding special tokens or formatting the messages in a specific way. The function then appends the human input to the conversation history. The function may apply additional formatting or instructions based on the additional quarks provided. Finally, the function generates the complete prompt string, which is ready to be sent to the LLM. Metrics. Prompt effectiveness measures how well the prompt guides the LLM to generate the desired output. This can be evaluated by examining the quality and relevance of the LLM's responses. Prompt clarity assesses the understandability and unambiguous nature of the prompt. A clear prompt reduces the chance of misinterpretations by the LLM. Prompt length evaluates the length of the prompt to ensure it's within an acceptable range for the LLM's processing capabilities. Visualization plots. Chat history visualization: a timeline or chart depicting the flow of the conversation, including the user's inputs and the LLM's responses. Prompt structure analysis: a breakdown of the prompt into its components, highlighting the key elements and their relationships. Fine-tune parameters. Temperature controls the creativity and randomness of the LLM's response. Higher values lead to more diverse and unexpected outputs. Top limits the number of possible next words considered by the LLM during response generation. Top filters the vocabulary based on the probability distribution of words, ensuring that less probable words are less likely to be selected. Uncertainty methods. Confidence scoring: assigning a confidence score to the LLM's response based on its internal probability distribution. This helps identify responses where the LLM is less certain. Ensemble methods: using multiple LLMs with different architectures or training data to generate responses and then combining them to improve accuracy and reliability. Challenges and fixes. Challenge 1: overly verbose prompts. Lengthy prompts can overwhelm the LLM and lead to inaccurate or nonsensical responses. Sample use case that resulted in Challenge 1: a prompt that includes an extensive chat history with many irrelevant details. Fixes to Challenge 1: trim the chat history to include only the most relevant turns. Use prompt engineering techniques to condense information without losing context. Challenge 2: ambiguous prompts. Unclear or poorly worded prompts can lead to misinterpretations and unpredictable responses from the LLM. Sample use case that resulted in Challenge 2: a prompt that uses informal language or lacks specific instructions. Fixes to Challenge 2: use precise language and avoid colloquialisms. Clearly define the desired output format and structure. Challenge 3. Prompt fatigue. Repeating similar prompts or using prompts with limited variation can result in LLM responses that are repetitive or lack novelty. Sample use case that resulted in Challenge 3. Consistently using the same prompt structure for multiple tasks. Fixes to Challenge 3. Experiment with different prompt structures and formatting. Introduce more variation and creativity into prompt construction. Langchain Prompty parsers. Description. Langchain Prompty parsers are a powerful tool for building complex language models that can understand and respond to natural language prompts. They allow you to define a prompt template that can be used to generate different prompts based on user input. This is especially useful for tasks like question answering, text summarization, and code generation. Inputs. Prompt the user input that the language model will process. This can be a question, a request for information, or a command. Prompt template. A template that defines the structure of the prompt. This template can include placeholders for user input, which will be filled in at runtime. Outputs. Processed prompt. The final prompt that is sent to the language model. This prompt will include the user input and the values from the prompt template. Response. The output generated by the language model. Steps. Parsing. The Prompty parser will parse the user input and the prompt template to identify placeholders for user input. Substitution. The parser will then substitute the user input into the placeholders in the prompt template. Generation. The final prompt is sent to the language model, which then generates a response. Metrics. Accuracy. This metric measures the accuracy of the language model's responses. Fluency. This metric measures the fluency of the language model's responses. Visualization. Plots. Prompt template visualization. A plot that visualizes the structure of the prompt template, including the placeholders for user input. Response visualization. A plot that visualizes the generated response, highlighting the parts of the response that are relevant to the user input. Fine-tune parameters. Prompt template parameters. These parameters control the structure of the prompt template. Language model parameters. These parameters control the behavior of the language model. Uncertainty methods. Confidence score. This method provides a score indicating the language model's confidence in its response. Multiple outputs. This method generates multiple responses to a single prompt, allowing the user to choose the most relevant response. Challenges and fixes. Challenge 1. Prompt ambiguity. The prompt might be too vague or ambiguous, leading to incorrect or irrelevant responses from the language model. Sample use case that resulted in Challenge 1. A user asking a question that could be interpreted in multiple ways, leading to the model generating a response that is not relevant to the user's intent. Fixes to Challenge 1. Use more specific prompts. Provide context, or use a prompt template that helps to clarify the user's intent. Challenge 2. Prompt length. Long and complex prompts can be difficult for the language model to process. Sample use case that resulted in Challenge 2. A user providing a long and complex prompt, leading to the model generating an incomplete or irrelevant response. Fixes to Challenge 2. Break down the prompt into smaller chunks. Use a prompt template that structures the prompt, or use a language model that is specifically designed to handle long prompts. Challenge 3. Data bias. The language model may be biased towards certain topics or viewpoints, leading to unfair or inaccurate responses. Sample use case that resulted in Challenge 3. A user asking a question about a sensitive topic, leading to the model generating a biased response. Fixes to Challenge 3. Use a language model that has been trained on a diverse dataset, or use a prompt template that helps to mitigate bias. Challenge 4. Prompt formatting. Incorrect formatting in the prompt can lead to errors or incorrect responses. Sample use case that resulted in challenge 4: a user entering a prompt with incorrect syntax, leading to the model generating an error. Fixes to challenge 4: use a prompt template that enforces a specific formatting, or use a language model that is robust to minor formatting errors. Challenge 5: memory limitations. The language model may have limited memory, making it difficult to handle prompts that require access to previous context. Sample use case that resulted in challenge 5: a user providing a prompt that requires information from previous interactions, leading to the model generating an inaccurate response. Fixes to challenge 5: use a language model that has a larger memory capacity, or use a prompt template that includes the necessary context information.